All right, we're going to continue with section 5.1. This time we're going to start simplifying. So all last week we did kind of what I call numeric problems, where you know that sine equals 3/4 or cotangent equals 1/2, and you had to find some of the other ones. So you have 6 trig functions that we've been talking about. So we're going to start working, and this is a little bit more abstract. We're not going to have really any numbers besides coefficients or exponents, which can be really confusing for some of you. So we're just going to have to work through it. Like I said before on these, the best way to get good at them is just to keep on trying and ask me questions, and we can work one-on-one via Zoom if you need to. Just email me. But we're going to talk about some different strategies that are going to help us with this. Definitely in the next section when we do something called verifying trigonometric identities, which is something kind of one of the big concepts that we talk about here in pre-calculus. So we are doing the backside of that original paper I gave you last week. So some of those guided notes that we kind of worked through, we'll continue to do that. This is just the second page. One strategy that we're going to use an awful lot the next couple of weeks is we're going to break down everything we can and get terms and get all these trig functions just into sines and cosines. And that sounds kind of weird. How would we do that? How do I get 6 different trig functions and get them down to be just 2? Well, first off, by definition, going from 6 down to 2 is definitely simplifying. But this is one strategy that's going to be very helpful. It's kind of like the bread and butter of trig identities. Well, here's how you do it. First off, if you see a sine or a cosine, you would just leave it alone. If you see a secant or cosecant, we would use a reciprocal identity. So if I see cosecant, I'm going to replace it with 1 over sine. If I see secant, I'm going to replace it with 1 over cosine. Now, another point to mention is if it's cosecant squared, then that's 1 over sine squared. If it's secant squared, that's 1 over cosine squared. Okay, so again, you see sine, you see cosine, you rewrite it. You see secant, you see cosecant, you use your reciprocal identities. If you see tangent or cotangent, we use our quotient, because tangent is sine over cosine and cotangent is cosine over sine. Now, the problem with all these type of simplifying and verifying that we'll do, there's not necessarily one way to do all of them. That's why it gets confusing. There's no step 1, step 2, step 3, solve the problem, done. A lot of time this strategy will work. It does not work every single time. Sometimes it's already in terms of sines and cosines. Okay, so what do? Well, we factor, we multiply, we do all sorts of different things. We're still going to use any of these identities that we've used before. This sine squared equals 1 minus cosine squared, we're going to use that a bunch. The cosine squared equals 1 minus sine squared, we're going to use that a bunch. If we see any of these, we'll use our Pythagorean identity. So these are things that you'll have in front of you. Hopefully you printed this off. That would be a good suggestion for you. But these are some of the things that we'll definitely need. Okay, let's do an example. So I have sine squared plus sine squared times cotangent squared. So there's a couple of ways I can do this one. But one, let's talk about that strategy that we were just discussing. So what I'm going to do is I'm going to start rewriting this. And what I'm going to do is I'm going to rewrite everything in terms of sines and cosines. So let's talk about what we do. If you see a sine or a cosine, you rewrite it. So I see sine squared, I'm going to rewrite sine squared. Then plus, I see another sine squared, I'm going to rewrite that. That's times by cotangent. I'm going to rewrite that in terms. Now, remember what we talked about. Sine or cosine, rewrite it. If you see a secant or cosecant, we use our reciprocal identities. I don't have that. Then we said if you see a tangent or cotangent, we're going to use those quotient identities. So this one says cotangent squared. So cotangent squared, you have a couple ways to do this. What I like to do is probably a little bit easier this way. Cotangent is cosine over sine. So again, cotangent is cosine over sine. So cotangent squared is cosine squared over sine squared. And the reason that works is because I'm taking that fraction and squaring the top and bottom. So notice that just by doing that one step, the only 2 trig functions I see are sines and cosines. Now we do what it says. It says to simplify. Now one thing, this is technically over 1. This is being multiplied. We're going to do a lot of fractional stuff. So you need to really brush up on multiplying, dividing, adding, subtracting. Now this is being multiplied, so I don't need a common denominator. If it was adding, I would. But notice you have a sine squared up top and you have a sine squared on the bottom. That means these cancel out completely. So both are sine squareds. So that's complete cancelization. So what am I left with? Well, over here, I'm still left with this sine squared. And here, I'm left with a cosine squared. And then over 1. Now, cosine squared over 1 is, of course, just cosine squared. And you wouldn't necessarily have to write that step I just did. Okay, how can I simplify this? Well, I'm hoping by now, if you've really worked at these problems, this should recognize this somehow. Because I go back to here, and that's one of the most important things that we'll do with trig identities. Sine squared plus cosine squared equals 1. So this, and I'm done. This is as simplified as I can get. Now, the problem with simplification is you might not know when to stop. When we do the next section, you'll have a stopping point that we'll get into. So this is just break it down as far as you can go. So we had this somewhat, mentally complicated kind of equation to simplify, and it breaks down, and that whole thing is equal to 1, which is interesting to me. And again, you don't get good at these unless you practice them. Let's do another one. So it says this. Now, this is like a physics equation. So the only thing we're going to break down are these tangent squareds and secant squareds. This v sub 0, see, that's initial velocity squared. That's going to stay there. 2 times g, that's 2 times the gravity. We're going to leave those alone. Those are going to stay with us the entire time. But everything else we're going to change. So I've got this. I'm going to start working with the top here. So same strategy. Let's break this down. So if we see a sine or a cosine, rewrite it. I don't have that. If I see a secant or cosecant right there, I'm going to use my quotient identity. So I'm going to go back and say that based upon that, that's secant squared. So secant's 1 over cosine, which means secant squared is 1 over cosine squared. So down here, I have this 2g. That's going to stay the same. I'm not going to mess with that. And then this secant is 1 over cosine squared. Up top, I have this v sub 0 squared, so my initial velocity squared, tangent. So we talked about if I did tangent or cotangent, we're going to use these quotient ideas. So tangent sine over cosine, which means tangent squared is sine squared over cosine squared. So now I have to simplify this. Now, a couple things. 1, I can write this over 1, and I can write this over 1. So why am I doing that? Because I want to get this to be one fraction here. Because when I multiply a fraction times a fraction, I multiply across. So these are both my numerators. So this is going to give me v sub 0 squared times sine squared over my denominators are 1 times cosine squared. So I'm just simplifying this top part of my fraction. So v sub 0 squared times sine squared, that's that. 1 times cosine squared gives me cosine squared. Then do the same thing at the bottom. I have 2g times 1, well, that's 2g, over 1 times cosine. So 1 times cosine squared is cosine squared. So I've got this fraction. So now I'm going to keep on going with it. Now, if I have a fraction divided by fraction, that's that whole keep it, change it, flip it thing. So the first fraction is going to stay the exact same. So the initial velocity squared times sine squared over cosine squared. That's the keep it. I change division to multiplication and then do the reciprocal at the bottom. So this becomes cosine squared. So again, we flip this bottom fraction. So cosine squared is on the top and then 2g's in the bottom. And then, as I keep saying, we do a lot of simplifying. I luckily have a cosine squared on the top and bottom. Now remember, you can only cancel if you have multiplication going on between them. You cannot do this if it was addition. So if I had addition, I'd have to get a common denominator. Here, it's multiplication. So if I have something on the top and bottom, I can cancel it, which is exactly what I'm doing. So what are you left with? Well, you're left with v sub 0 squared times the sine squared up on top. And on the bottom, you're left with 2g. This is as far as I can go. So why are we using this? Well, if I'm talking about an angle for physics, it's a lot easier. Someone may have derived a formula that look like this. That would involve more calculations with tangent squared and secant squared. It's so much easier to use this because I just have a sine function here. And so again, some calculators only have sine, cosine, and tangent on them. They don't always have this. So it's a lot easier to be able to use one that's first off one trig function and second off it's just a sine value. So it's a lot easier to say, okay, well, let's say the angle in question is 30 degrees. Can I plug it into this and get the same answer as this? Yes, but this one's a lot nicer, a lot cleaner. So this is kind of the start of what we're going to continue to do.